Hello, I'm Siyona Bose, and welcome to my channel, Learning Builds Life. And today we're going to learn how to find quick factors of cubic polynomials. But before we begin factorizing our cubic polynomials, I have a small request. Please watch this video till the end, because this is very useful for students, skilled students, especially from class 9 to 12. Now we can begin factorizing our cubic polynomials. But before we find quick factors, we need to find how to basically do it, because quick factors are done in a different way, and the basic way I'm doing first. In the first polynomial, we have x cubed plus 2x squared minus x minus 2. Clearly, we can see we can take common factors from each of the pairs of terms in this polynomial. But for these rest three polynomials, there's a different method, which we're going to see when we reach the second one, third one, and fourth one. But let us solve this one. Well, let us factorize this one first. In our first pair, we can take x squared common. Very vivid. And we're left with x plus 2. For our second pair, we take minus 1 common, but we take minus 1 common, I know that, but we won't show minus 1. That's a bit too childish. We just show a minus sign and write x plus 2. Now, the common factor is x plus 2, so we write that first. And we get x squared minus 1 as leftover terms. This can be factorized into x plus 1, the whole, into x minus 1. This polynomial is factorized into this, and the whole factorization is x plus 2 the whole into x plus 1 the whole into x minus 1 the whole. This is the conventional method. Now we'll see what are the second, third, and fourth polynomials special about. Our next polynomial is x cubed minus 2x squared minus 5x plus 6. Say carefully, in this polynomial, we can take common factors from these two pairs. We can take common factors from these two pairs of terms from this polynomial. Instead, we can use a different method that is called factor theorem. In factor theorem, we need to take a value for substituting x for, and until our substitution, the substituted polynomial can give us 0, we can't find the factors. You must have seen our previous episode, the special kind of quadratic polynomial, where we substituted x's value and got our factors. Cubic polynomials are factorized in the same way. The first value we take for x is 1. If we take the value of x as 1, then we have 1 cubed. For 1 cubed, you can write 1 itself, but I'm just demonstrating the calculations too. Then we write 2 into 1 squared minus 5 into 1 plus 6. Let us see whether this, after solving, gives us 0. 1 minus 2 minus 5 into plus 6. Plus 6. First, we need to take the positive terms, numbers with the same sign in consideration, and then we solve it. So we took 1 plus 1 and plus 6, which gives us 7, and minus 2 and minus 5 gives us minus 7. Clearly, it gives us 0, and one of our factors of this cubic polynomial is x minus 1. And now, we need to find our term for the second bracket. our polynomial, because in the second bracket we're going to get a polynomial, and that polynomial again needs to be factorized into 2 more factors, and then we get 3 factors in whole. Let us find out what's written in the second bracket. The first thing we need to write is x squared, because a multiplication of x squared into x, it gives us x cubed. And here we have minus 2x squared. See, for so long we have been considering without the sign, but here we need to consider with the sign, minus 2x squared. But already previously we had 1 minus x squared from multiplication of this. We had a minus x squared, you can see. We need another minus x squared. How to get that? We write a minus x over here, because in multiplication of x and x we get minus x. Minus x into x gives us minus x, and minus x squared gives us minus 2x squared. And we now need to take care of this linear term. We can straight away move on adjusting the constant. Our constant term is minus 6, because a multiplication of minus 6 into minus 1 gives us positive 6, which tells us, which is the constant term in our polynomial with the sign. And now we have already learned how to factorize these kind of polynomials. Our factorization is x minus 3 the whole into x plus 2 the whole. For this quadratic polynomial, this is the factorization, in all, the factorization for this cubic polynomial is x minus 1 the whole into x minus 3 the whole into x plus 2 the whole. Our third polynomial is x cubed minus 3x minus 2. Clearly, this has to be solved with factor theorem, because first of all, we can't form a pair. It's done there itself. We need factor theorem. First value you need to take is 1, obviously. Now, values may fail. It's not guaranteed it's always going to be 1. It can be 2, it can be minus 1, it can be 3, minus 3, whatever, if it fails. Let us see what happens in this polynomial. On substitution for x is 1, we have 1 cubed minus 3 into 1 minus 2. We write 1 minus 3 minus 2. Clearly, this cannot give us 0. Clearly. You can solve it mentally. We have 1 minus 5. It can't give us 0. We have to take another value. But that value is not 2. We can't straight away go from 1 to 2. We have to consider the negative numbers too. We have to go to minus 1. And if minus 1 fails, then it goes to 2. First, let us take minus 1. Minus 1 cubed minus 3 into minus 1 minus 2. We write minus 1 plus 3 minus 2. We get minus 3 plus 3 equals 0. If we got minus 1 as the number which is satisfying, then we have to write x plus 1 as one of the factors. Now we need to get our quadratic polynomial in the second bracket. How to get that? The same way we did in our previous polynomial with factor theorem, obviously. There, we first obviously wrote the x squared, because in multiplication of x squared and x we get x cubed. Now we need 0x squared, because we don't have an x squared term. To get 0x squared, we already had 1 plus x squared with us. We need a minus x squared. How to get that? We need to write a minus x, because in writing minus x, we get a multiplication of minus x into x, this is minus x squared, and we already had a plus x squared. The two cancel out, and we're left with 0x squared. And finally, we adjust our constant, as you know, and we write minus 2. We write minus 2 because on multiplication of minus 2 into plus 1, we get minus 2, the constant term in this polynomial with the sign. And this polynomial, I know, can be factorized super fast. X plus 1, the whole, into x minus 2, the whole, into x plus 1, the whole. But we are not done here yet for this one, because there's one more step actually. Say, we have 2x plus 1 factors here. So how to adjust that? We need to write x minus 2 the whole x plus 1 whole squared. Our last and final polynomial, x cubed minus 7x plus 6. Clearly, in this polynomial too, we need to use factor theorem and not take pairwise, because first of all, we can't have a pair. There's no question about it. We need to use factor theorem here. And again, take care of the values. First value we use is 1, obviously. We write 1 cubed minus 7 into 1 plus 6. 1 minus 7 plus 6. Minus 6 plus 6 gives us 0. So we finally can conclude that 1 is our factor, x minus 1. Get x minus 1. So one of the factors is x minus 1, it's x minus 1. And if you want, you can even check what you did. See, again, we verify 1 cubed minus 7 into 1 plus 6. 1 minus 7 plus 6. 1 minus 7 gives minus 6 plus 6 gives 0. So it's perfectly correct. X minus 1. Now I need to get quadratic polynomial in our second bracket. We get that, obviously, first we need to write x squared. Then we write, why would we write x squared? You already know that, because x squared on multiplication of x, it gives us x cubed, which is our first term in this polynomial already. Now we need to write the linear term of this quadratic polynomial. We write that, means to get that, first we need to consider this. We have minus x squared, and we need 0x squared. We need to get a plus x squared. How are we getting it? We write plus x, because on multiplication of plus x into x, it gives us plus x squared, and we already had a minus x squared. It gives us 0x squared. And now we need to take care of the constant, and we write minus 6 once again. Minus 6, because on multiplication of minus 6 into minus 1, it gives us plus 6, which is a constant term in this polynomial, with the sign, of course. X minus 1. And then we factorize this polynomial very fast, and we know the method, what it is. X plus 3, the whole, into x minus 2, the whole. Now I have a sum for you all. The sum is x cubed minus 5x squared plus 10x minus 6. I'm giving a few moments for you all to copy the sum. Please write your answers, and please write your factorizations. I'm very sorry. Please write your factorizations for this polynomial in the comment section below. And please like, share, and subscribe my channel. Thank you. In the next blog, we will discuss on episode 6, which is quick or synthetic division. Please subscribe my channel and press the bell button.